In this section, we discuss another application of derivatives. This application is called related rates. What do we mean by related rates? If we have a quantity Q that's changing over time, then the derivative of Q with respect to t is called the rate of change, or the rate at which Q changes over time. And in many applications, we are given two or more quantities. For example, we may be given the two quantities P and Q, and we know the derivative of P with respect to t, so that means the rate of change of the quantity P with respect to t, to time t, is given, and we want to find dq over dt, the other rate of change. So this is not given, and in this case we need to find some relationship between P and Q, and we usually are given either an equation or a function that presents some relationship between P and Q, or we need to use one of the mathematical formulas to find that relationship between P and Q. So in general, we have the problem of related rates consists of the following things. We have two or more related quantities. Related quantities, that means there's some relationship between P and Q. One of these related rates is given. And we want to find the other. The other related rate. So let's take an example. If we have a circle of radius r, and that radius is increasing at a rate of 10 centimeters per second, we want to know how fast is the area increasing at the instant when the radius has reached 5 centimeters. So here for this problem we have a circle of radius r, and r is increasing, so dr over dt is 10 centimeters per second. So the rate of change of the radius with respect to time is 10 centimeters per second. As r is increasing, what happens to the area? As r increases, area will increase accordingly. For example, if the radius becomes this, then as you can see, the area will be larger. So here, for this problem, we have two quantities, radius and area, and we want to find some relationship between them. So area is pi r squared. This is the basic relationship between area and the radius, or area of the circle and its radius. Now we want to find how fast is the area increasing. So we want to find dA, the rate of change of the area with respect to time, at radius equals 5, when radius equals 5. So to find this, we need to find the derivative of the basic formula. So what is the derivative of this? We differentiate with respect to t. So whenever we differentiate a or r, we need to multiply by the derivative with respect to t. So derivative of a is dA over dt equals pi. What is the derivative of r squared? Is 2r dr over dt. Now we want to find dA over dt at r equals 5. That means we need to substitute r equals 5. So this is 2 pi 5 dr over dt. dr over dt is given, it's 10. So we have 100 pi, or approximately 314 centimeters squared per second. That's the rate of change of in area with respect to time. So thus the area is increasing at the rate of 314 centimeters squared per second when the radius is 5 centimeters. Another example, Selma is at the top of a 5-foot ladder when it starts to slide down the wall at a rate of 3 feet per minute. John is standing on the ground behind her. How fast is the base of the ladder moving when it hits him if John is 4 feet from the ground at that instant? So let's graph this problem. We have a wall here and a ladder standing on that wall. And Selma is here. John is here. Now we have the ladder slides down at some rate 3 feet per minute. So that means if we denote this height, the height of the ladder, by y, then we have dy over dt. This is given, but since this rate of change is, or this, the change of y over time is decreasing because this slides down at rate of 3, we put negative sign. So negative 3 feet per minute. That's why we put the negative sign, because the vertical length, or the quantity y, is shrinking over time. And let's denote this distance by x, and as we can see, this is increasing as y is decreasing. So dx over dt, we want to find this. How fast is the base of the ladder moving when it hits John? So that means x will be changed over time and increased over time. So we want to find dx over dt when John is 4 feet, when x is 4. So this is the quantity that we want to find, and this is the quantity that is given. So if we look at this graph or shape, we can notice that we have a right angle triangle, and the length of the ladder is 5 foot, so this is constant. Now we find the relationship between x and y. So the relationship is that x squared plus y squared equals 5 squared. The Pythagorean theorem. So this is the basic relationship between the two quantities, x and y. Now we find the derivative, 2x dx over dt. So we multiply by derivative with respect to time every time we derive the quantity, plus, or we differentiate the quantity. Y squared is 2y dy over dt equals, what is derivative of 5 squared? It's 0. Now we have these derivatives. We have the nu formula that's based on derivatives. Now we want to find dx over dt. This is unknown. X is given, it's 4. We want to find this at 4, x equals 4. Y is not given, and dy over dt is given as well. So we need to find y. How to find y? We use the basic formula. what is the basic formula? The basic formula is x squared plus y squared equals 25. X is 4, so 4 squared plus y squared equals 25. 16 plus y squared equals 25. That means y squared equals 9, and thus y equals 3. Now we can apply the formula here. We have 2 times x is 4, dx over dt, plus 2 times y is 3, dy over dt is negative 3, equals 0. Now 2 times 4, 8, dx over dt, 2 times 3, 6 times negative 3, negative 18, equals 0. Now we solve for dx over dt. Dx over dt is 18, positive 18 over 8, and that's 9 over 4. Now this is feet per minute. Now let's do another example. This quantity was evaluated at x equals 4. Okay, the third example is the following. The costs to manufacture X cell phones in a day is given by this formula, or this function. The daily production level is currently X equals 5,000 cell phones and is increasing at a rate of 100. Now, we have 100 units per day. We want to know how fast is the average change changing. So we want to know how fast is the average cost is changing. Now we need to find derivative. That means we need to find derivative of the average cost, because this is the objective function. The average cost, we need to find it first. It's C of x, the total cost, over x. So this is, we need to divide C of x by x. We get 10,000 over x plus 20 plus x over 10,000. So we have this basic function. Now we want to find how fast is the average cost is changing. That means we want to find the derivative of this with respect to time, or with respect to x in this case. Now the question is, what is the related change of C bar with respect to time? They should be changed over time. So we want to find dC bar over dt. But as we can see here, C depends on x, C bar depends on x. And then when we differentiate x, we need to multiply by dx over dt. Now we are given that dx over dt is 100. Here we read, and is increasing, the daily production level x is increasing at a rate of 100 units per day. So dx over dt is 100 units per day. Now we have two quantities, dx over dt and dc bar over dt. We need to find the derivative of this. So dc bar over dt is equal to, what is derivative of this right hand side? Derivative of the first quantity is negative 10,000 over x squared. You can apply the quotient rule to find this. Plus derivative of 20 is 0, plus derivative of x over 10,000. This is equivalent to 1 over 10,000 times x. What is derivative of this? Derivative of this is 1 over 10,000. Constant times x. So the derivative is just the coefficient of x. Now we need to multiply this by dx over dt because we are differentiating with respect to time. Now to evaluate this dc bar over dt at x equals 5,000, the level is, we want to evaluate this when x equals 5,000. This is negative 10,000 over 5,000 squared plus 1 over 10,000 all multiplied by dx over dt, but dx over dt is 100. And then we can use the calculator to simplify this, or we can do it by hand. If we want to simplify by hand, we can write negative 10,000 over 25 millionth plus 1 over 10,000, all multiplied by 100, and then we can delete 4 zeros from this, 4 zeros from this, and then multiply by 100. So we get negative 100 over 2500 plus 100 over 10,000. And this gives, let's simplify more. This gives negative 1 over 25 plus 1 over 100. Now we multiply this by 4 to get a common denominator. We get negative 3 over 100, which can be written as negative 0.03 dollars per day. So the rate of the average cost is decreasing because the derivative is negative. As we can see, if the rate of change is negative, that means the quantity is decreasing. So this is the average cost is decreasing by 3 cents per day. Now the last example here is that the following one. An athletic sport clothes company manufactures athletic t-shirts. Production is partially automated using robots. The number of t-shirts that company can manufacture in a day is given by this formula, where in this case Q represents number of t-shirts, N number of laborers, R is number of robots. Now the company currently produces 1,000 t-shirts each day and employs 20 laborers. This is N. It's bringing one new robot online every month. So if we denote number of robots by R, so it's bringing one new robot every month. That means the change in number of robots over time is equal to 1. One robot per month. Now at what rate, this is the question, at what rate are laborers, so we're asked to find dn over dt. being laid off, assuming that number of t-shirts produced remains the same. So that means we want to find dn over dt when n equals 20. Okay, so that's number of laborers. Now, by looking at this problem, we find that the changing quantities are number of laborers, n, so the quantity is dn over dt, and number of robots, so dr over dt is a quantity that's changing over time, and one of them is given. Dr over dt is given. It's one robot per month, and this quantity that we need to calculate or to find dn over dt when number of laborers is 20. Now we need to focus on the formula that's given. It's Q equals 50. Q equals 50 n to the power 0.6 times r to power 0.4. Now Q represents number of t-shirts. This is constant. Now we find the derivative with respect to time t. So differentiate both sides of this equation. What is the derivative of q? It's 0 because q is constant. Now what is the derivative of the right hand side? We have two parts. Let's use the first part is 50n to 0.6 and the other part is r to the power 0.4, and as we can see this we can apply product rule when we differentiate. So the first times derivative of the second, or some people prefer to start with derivative of the first times the second plus first times derivative of the second. Let's apply this. Derivative of the first is 50 times, what is derivative of n to the power 0.6? The power times n to the power minus 1 times dn over dt, because we are differentiating with respect to time. This is derivative of the first times the second is r to the power 0.4. So derivative of the first times the second plus the first times derivative of the second. What is derivative of r to the power 0.4? It's 0.4 r to 0.4 minus 1 dr over dt. Now in this formula we have n is known, this is 20. R is, now we need to find r. R is unknown. dn over dt is unknown. dr over dt is given. This r is unknown. N is given. Okay, so how to find this? We need to substitute what we know in this formula, but to find r, what is r? We use the basic formula. The basic formula is q equals 50 n to 0.6 r to 0.4. Now q is 1000. Q is 1000 equals 50 times 20, n is 20, to 0.6 to the power 0.6 r to the power 0.4. Now we solve for r by dividing both sides by this quantity, and that gives us r equals r to 0.4 equals 1000 over 50 times 20 to the power 0.6, but 4 is 0.4 is 4 over 10. Now to get rid of this power, we raise both sides to the power 10/4, the reciprocal of the power over r. So these cancel, and we get r equals 1000 over 50 times 20 to the power 0.6, or raised to the power 10 over 4. And we can use the calculator to find this. This will give us 20. So r is 20. Now r is given, so we substitute it here into this formula. We have, after differentiating the basic formula, we substitute r and dr over dt to find dn over dt. So substituting that, we get 50 times, we have 50 times n is 20 to power 0.6 times 0.4 over 20 to the power 0.6 times dr over dt, plus we substitute here. So we substituted this part first, and then we substitute, let me rewrite it here to make it easy for you guys to follow. So we have 50 we have, let me write it here. So we have 0 equals 50 times 0.6 n to the power 0.6 minus 1. 0.6 minus 1 is negative 0.4. Negative 0.4, when we bring it down, it becomes positive 0.4. So we can erase this. And dr, or r to the power 0.4, r is 20 to power 0.4 times dn over dt, plus, now this quantity, 50 times n is 20 to the power 0.6 times 0.4 times r is 20 to the power 0.4 minus 1 is negative 0.6. We can bring it down here, becomes 20 to the power 0.6. And we have dr over dt. dr over dt is 1. Okay, now we simplify more. We can cancel this with this. We can cancel this and this, and we get 30 dn over dt plus 20, because when we multiply 50 by 0.4, we get 20 times 1 is 20 equal to 0, and then we solve for dn over dt. It's negative 20. We bring this to the right hand side and divide by the coefficient of dn over dt. So simplify more, you get negative 2/3. So the company is laying off laborers at a rate of 2/3 laborer per month, or 2 every 3 months. And as we can see, the quantity n is decreasing. That means shrinking, and that means we have